Good morning, boys and girls. Today we are back to science. Now it's been a minute and I apologize for that. One of the things that I am trying to do is keep your learning in line with the learning that the in-person friends are doing. So that way if you do switch back, you'll be, for the most part, right on point with what they're learning so far, so you'll know what they know. But also because your guys' report cards are the same too, so we have to do the same, we cover the same material and concepts. And if you were in person, and they're not doing it this year, so on a typical year, I guess I should say, we, in second grade, do rotations, so one teacher teaches each subject. Last year, I was the math person, so I got to review math facts and play fun math games with friends. The science person for second grade is Mr. Clinton. I'm not sure if you guys know who that is or not. So when I teach you guys science and when I teach you guys social studies, I do like science. So I know a little bit more about science, and I get a little bit more excited about that. But I do follow what they are doing, and he has all of that stuff. So they were a little bit behind themselves, so that made us be a little bit behind, but that's okay. So we're getting back on track. We're talking about matter. I forgot, it's been so long. And while I'm thinking of it, I also owe you guys some pages too. Talk to you about solids, liquids, and gases. Remember that matter is anything that takes up space. So the weight of something is not matter. It has to take up space, okay? And we'll do an experiment on Thursday, I believe, to show that all states of matter do in fact take up space. So we're going to be talking about particles today. We kind of talked about how everything that we touch, everything that we see is made up of particles, even the air that we can't see, but if we move our hand, we can feel it, we're breathing it, we can kind of feel it that way. Even the air has particles in it too. So you have this half sheet of paper. I need you to cut around the dotted lines. And then we're going to make a flat book. So you're going to cut this dotted line and this dotted line, but you're going to stop at this solid line. Okay? If you give me just a second. I maybe should have told you those directions, and then I could have been cutting while I was talking. But that is okay. So we're going to make a flip book by gluing this into our science notebook. And then underneath each flap, we are going to draw what the particles look like for that state of matter. Okay? Okay, so my pieces are all stuck together, but this flap is holding the strips together. When you go to glue, let me find my glue real quick, you're going to glue just on the edge that is not cut. You don't want to glue the flaps that you cut, otherwise you're not going to be able to lift them. So, whoops. Alright, just going to glue this. I like mine to be straight, so I'm going to use the red line for a guide. Still going to get it super straight, but that's okay. Straighter than I would have if I just threw it on there. Alright, so here's this. Let me get this stuff out of the way. For a solid, remember we said that the particles, I do all of my pencils disappear. We said that the particles are super close together, so that way we can feel it, and my hand doesn't go through the table. The particles on the table are so close together that my hand doesn't just go whoop, right through the table. Okay? So, I'm going to fold this like this, and I'm going to put a little crease in it. For a solid, the typical way to draw a particle is just a circle. And for a solid, the circles are super close together. Okay? I'm going to make maybe 3 rows of super close together particles. Uh-oh. I'm getting a little farther apart. Make sure they're touching, make sure they're close together. Okay? And these particles don't just sit here, they vibrate back and forth. But they're so close together that they're always touching each other, but they vibrate back and forth. Okay? So this is what a solid looks like. This is what the particles inside our table look like. For a liquid, I'm going to draw a cup because the fun thing about a liquid is it takes the shape of its container, but they are a little more spread out. Okay? So there's spaces in between them. Okay? I guess I can leave these flaps open like this. And then for a gas, I'm also going to draw a cup. A gas fills its container as well, or it takes the shape of its container. But a gas is crazy. They are super far apart. I'll put it there. They're super far apart. And my cup doesn't have a lid on it, so some are escaping. Put another one right here. Some are escaping. There's probably one right there too. Yeah. Gas particles are super far apart. Super far apart. So solid, we can even make a little note so that way we remember. Close together. Touching. And holds its shape. Holds its shape. What that means is that if I take this desk and I put it outside, it's still going to be in desk shape. Okay? For a liquid, hopefully you used a pencil. I'm going to change this. They are close together, but the important part is that these ones are touching, whereas a liquid is close together and they're not touching. So particles are touching, okay? For a liquid, particles are close together. And for a liquid, they kind of will like flow around each other and then go to take their shape, or to take the shape of the container. They spread out to take the shape of the container. So close together takes the shape of container. So if I pour this cup into my rectangle Ziploc little plastic what am I thinking of? the Ziploc plastic like food saver bowls, it's gonna go from this cup shape to the rectangle shape, right? Because it takes the shape of the container. Air particles are far apart. And they move fast. Air also takes the shape of the container. Sorry, I'm calling this air. It is a gas. Air is a gas. And what that means is that when I am in my classroom, the air is the shape of the classroom. And my air that I am exhaling goes out into the classroom and it spreads out to take up that big whole space. But if I exhale my air into a balloon, my air stays the shape of the balloon. Okay? So for a gas, it takes the shape of the container, but the particles are far apart and they move fast. Okay? Alrighty, guys. This is all we have for today. So if you need to pause the video to finish your pictures or your notes, go ahead, do that. Once you're done, go ahead and flip your folds back over. Okay? And then thanks for hanging out with me. On Thursday, we're going to do a little experiment. I'm going to show it to you, and then I hope that you can try it at home to see for yourself because it's pretty awesome. Have a great day, guys.